Hi everyone. In this lecture, I'm going to explain the topic quick sort. So sorting is nothing but arranging the elements in a particular order, either in ascending order or in descending order. There are so many sorting techniques are there. Some of them are merge sort, quick sort, bubble sort, insertion sort, selection sort, heap sort, etc. So here in this lecture, I'm going to concentrate mainly on quick sort. Quicksort is one of the sorting algorithm which uses divide and conquer strategy. So first of all, we need to know what is divide and conquer. So divide and conquer is one of the strategy used in algorithm to design an algorithm. So divide is nothing but divide the whole problem into P1, P2, Pk sub problems until P is smaller one. So conquer is nothing but the process of solving the each and every sub problem recursively. So combine is nothing but combining all the solutions of the subproblems to get the solution for the given problem. So this strategy is said to be divide and conquer. When you are going to use this divide and conquer in the sense, if you are having two or more recursive calls in a particular algorithm, then we need to go for divide and conquer. So this divide and conquer can be used in merge sort as well as in quicksort. Right. Then here the divide and conquer technique can be used as the first one, divide. So divide is in this divide splitting the array into two sub arrays that each element in the left sub array is less than or equal to the middle element, and each element in the right sub array is greater than the middle element. Here the splitting of arrays into two sub arrays is based on the pivot element. The pivot element can be choose based on the first element as a last element or the middle element. In my example, I have been chosen the first element as the pivot element. All the elements that are less than the pivot element should be in the left subarray, and all the elements that are greater than the pivot element should be in the right subarray. The pictorial representation of that is given here. So, and then conquer. The process of getting the solution for recursively in two sub arrays is said to be a conquer. And combine. Combine all the sorted elements in a group to form a list of sorted elements. That is the main aim of your quick sort. So, for example, consider the following elements as input for the quick sort, and these elements are stored in an array A. So the aim is to sort the above elements in ascending order by using the quick sort. Here, the first element, that is a of 0, is going to be assigned for low as well as I as well as the pivot element. And the last element, that is a of n minus 1, is going to be assigned for high as well as j. Now I have been chosen the pivot element as the first element, and I is located at the starting element and j is located at the last position. We will now split the array into two parts based on the pivot element in such a way that the left sublist will contain the elements less than the pivot, that is 50, and right sublist will contain the elements greater than the pivot element. Now the first element is the pivot element and I is also the first element, and j is located at the last element. Based on the function partition, I'm going to split this whole array of elements into two sub arrays, left sub array as well as right sub array. So here initially, I is located in the first location and j is located at the last location of an array. So here the first condition is while I is less than j, do. So while a of I is less than or equal to 5. So here the value of a of I is 50 and the value of pivot is also 50, which is a of I is equal to pivot element. So I need to increment I is equals to I plus 1. So I position will be incremented by 1 position. So now A of I value is 30 and my pivot element is 50. Now here A of I is less than pivot. If A of I is less than or equal to pivot, I need to increment I by 1 position. So here I will be incremented to 1 position. Now A of I value is 10 and my pivot element is 50. Here A of I is less than the pivot. So I need to increment I value by 1 position. So here A of I is equals to 90 and my pivot element is 50. So here A of I is greater than the pivot element. So here the first condition fails. So it will goes to the second condition. Now I need to check with A of j. A of j, here A of j is 70 and A of my pivot element is 50. Now A of j is greater than my pivot element. So I need to decrement one position, right, the j. So the j position will be decremented by 1 position. See it here. So j will be decremented. Now, so my j value is 50 and my pivot element is 50. Sorry, j value is 40 and my pivot element is 50. So A of j is less than pivot element, but the condition is A of j is greater than pivot. So the condition fails. So if it fails, I need to check one more condition. If I is less than j, yes, I is here, I is in this location and j is here. So I is less than j. So I need to swap A of I and A of j. By swapping A of I and A of j, the output will be like this. Now I is located here and j is located here. So I need to start from the beginning. Right. So yeah, here A of I is 40 and my pivot element is 50. So A of I is less than my pivot element. If A of I is less than my pivot element, I need to increment I. So I will be incremented to this position. Now A of I is 80 and my pivot element is 50, which is A of I is greater than my pivot element. Condition fails. This condition will fail. So it goes to the next condition. So A of j. Here A of j is 90 and my pivot element is 50. So condition true. So I need to decrement the value of j by 1. So j will be decremented from here to here. So now the j is 20 and my pivot element is 50. Here A of j is less than pivot. So the condition fails. So I need to check for this condition. I is less than or equal to j. So here I is less than j. So the condition true. So I need to swap A of I and A of j. So by swapping these two elements, I got this output. So here I value is 20 and my pivot element is 50. So A of I is less than my pivot element. So I is equals to I plus 1 incremented by 1 position. So I will be 80 and my pivot element is 50. So here A of I is greater than my pivot. So the first condition will fails. Then I need to go for second condition. Here I need to check with in terms of j. So the j value is 8. A of j value is 80 and pivot element is 50. So which is greater than A of j is greater than the pivot. So condition true. So j is equals to j minus 1. So j will be decremented. So now a j value is 20. So if j will be decremented, the j will comes here. Now I can, the first condition itself fail. I is greater than j, but I need to have I is less than j. So swap the pivot element. It comes here. So swap the pivot element as well as A of j. So by swapping these two elements, I got the output like this. So 20, 30, 10, 40, 50, 80, 90, 70. So this is the pivot element. So the elements which are left side of it is less than the pivot element. The element present in the right side of it is greater than this pivot element. This is what the work done by the partition algorithm is. Now consider the left subarray, apply the partition algorithm. So the left subarray is nothing but 20, 30, 10, 40. So here by using this partition algorithm, the first element will be considered as a pivot element as well as a of I. And a of j is nothing but the last element. Here a of I is equals to pivot. So I is equals to I plus 1. So the I will be incremented here. So here I value is of I value is 30 and my pivot element is 20. So the first condition will fails and it will check with the second condition that in terms of j. So a of j is now here a of j is equals to 40 and my pivot element is 20. A of j is greater than pivot, so j will be incremented. So if j will be decremented. Okay, so now a of j value is 10 and my pivot element is 20. So here a of j is less than pivot element condition fails. I is so this condition is also fails. So it will goes to the next condition, that is I is less than j. Yes, swap a of I and a of j. So by swapping these two values, so I got this output. So 20, 10, 30 and 40. So here a of I is less than the pivot element, so I will increment I value by 1. So I will comes here. So now a of I is equals to 30 and my pivot element is 20. So a of I is greater than my pivot element condition fails. So I need to go for the second condition, that is a of j is and a pivot element. So here a of j value is 30 and my pivot element is 20. So a of j is greater than my pivot element, condition true, then j is equals to j minus 1. So j will be decremented by one position. So now here I is greater than j. So swap the pivot element as well as a of j. So by swapping these two elements, I got the output as 10, 20, 30 and 40. This is the left sub array and this is the right sub array. The elements present in the left side of the pivot is less than the pivot element. The elements present in the right side of the pivot element will be greater than the pivot element. So like this, we need to do the quick sort until it arranges the elements in ascending order. So this is the algorithm which you are going to use for quick sort. So here what you have been done is quick sort. The input will be array of elements. The lower position will be the first starting element of an array. Higher position is nothing but the last position or last element present in the array. So if low is less than high, it means that if array contains two or more elements, then only we can perform the quick sort. M is the position where the partition, that is pivot element, is going to be placed, and then after partitioning the elements, then I need to use quick sort. For the first half, I need to call the quick function. For the second half, the first half will start from low to m minus 1 and the second half will start from m plus 1 to high. Clear? So then this is the partition algorithm. I think you have clear about it. Then the time complexity for quicksort is the recurrence relation for the quicksort is T of m is equal to T of n by 2 plus T of n by 2 plus n. So this T of n by 2 is the time required to sort a left sub array, and this is the time required to sort right sub array, and this n is time required for partitioning the sub arrays. So this equation can be written as T of n is equal to, there are two times of T of n by 2. So 2 into T of n by 2 plus n. This is equation number 1. So substituting here n equals to n by 2, then I got this equation. If I substitute n is equals to n by 4, I got the equation number 3. If I substitute equation 2 in 1, I got so 2 into, instead of t of n by 2, I'm going to substitute this whole equation, that is this. So 2 into t of n by 4 plus n by 2 plus this n will be here. So 2 into 2, 4, t of n by 4, 2 into n by 2. So 2 gets cancelled, n plus n will becomes 2n. So here 4 t of n by 4. Instead of t of n by 4, I'm going to substitute equation number 3. So it becomes 4 into, instead of t of n by 4, I'm going to substitute 2 into t of n by 8 plus n by 4 plus 2n. So 4 into 2, 8, t of n by 8 plus 4 into n by 4. So 4 gets cancelled, n will be here, n plus 2n, that becomes 3n. So t of n is equals to 8t of n by 8 plus 3n. This equation can be rewritten as 2 cube t of n by 2 cube plus 3n. So in terms of k, so t of n can be written as 2 power k, t of n divided by 2 power k plus k. So if I assume that n is equals to 2 power k, then k becomes log n base 2. So by substituting these values in the above equation, I got n, instead of 2 power k, I'm going to substitute n into t of n divided by n plus n log n base 2. So here n gets cancelled, t of 1. So t of 1 value is equals to 1. So I'm going to substitute 1 into n, that is n log n base 2. So here, so the time complexity can be written as, for the quicksort, can be written as order of n log n base 2. Thank you.